Greg Troutwine with Marine Technology TV, and we're very pleased to be joined today by Dave Fretantoni, the CEO of the Neil Brown Ocean Sensor Incorporated, or NBOSI, to discuss his company and technology, as well as his outlook for the market. Dave, to start us off, can you provide an overview of NBOSI, the elevator speech, if you like, to give our viewers an insight on what you do?
Sure thing. Well, thanks, Greg, for this opportunity to speak with you and your viewers. NBOSI is by no means a new company, but we are placing new emphasis on increasing our global visibility. And so this chance to chat with you in this forum is greatly appreciated. In a nutshell, we build CTDs for AUVs. Neil Brown Ocean Sensors develops accurate, rugged, reliable conductivity-temperature-depth sensors, CTDs, that are custom designed for integration with autonomous marine platforms of all types, AUVs, ASVs, gliders, ROVs, and everything in between. Our strengths as a company really are our vast experience in ocean measurement and our ability to focus on the unique requirements of each customer. Temperature and salinity are fundamental physical characteristics of the ocean environment. And as an ocean scientist myself, I appreciate the value of measuring temperature and salinity because of their sort of fundamental role in shaping ocean dynamics and influencing ecosystems. Right, they are the fundamental measurements of our operating space. But as an engineer and a vehicle operator myself, I also understand that accurate temperature and salinity can yield important information about things like ocean density and sound speed that have direct impact on vehicle and payload performance. I would argue that measuring temperature and salinity from any platform is a really good idea, but autonomous mobile platforms in general are almost always power and size and space limited, and they're often designed from the beginning for really challenging missions that emphasize robustness, reliability, and hydrodynamic efficiency. And because of that, there's really no one off-the-shelf CTD solution that's going to fit this cornucopia of AUV and ASV designs out there today. And building a vehicle around a CTD, which, let's admit, is probably not the primary purpose for that vehicle, just doesn't make a lot of sense. So NBOSI specializes in adapting our unique sensor technology to best support each customer's unique platform in an efficient and actually, frankly, quite affordable way. So we build CTDs for AUVs, but we do it in a way that it reflects the needs of each customer individually.
Can you give us a by the numbers look at NBOSI today, something that provides the size and the shape to the company using the metrics of your choice?
Sure thing. So as background, the company was spun out of the Woods Hole Oceanographic Institution in 2003 and was founded by three people. The legendary Neil Brown, who's just an extraordinary engineer and inventor of the CTD. Dr. Ray Schmidt, who's perhaps the world's foremost expert on ocean salinity measurement, and Bob Pettit, who's a highly experienced and creative electrical engineer at WHOI. As a WHOI scientist myself at that time, this is going back 20 years ago now, I was actually customer number one and applied early versions of the NBOSI sensor technology to my fleets of Web Research, now Teledyne Slocum gliders, Ocean Server Ivor 2 vehicles, I guess they're now L3 Harris, and Liquid Robotics Wave gliders. So while I was not there at the functional formation of the company, I've been familiar with this technology for a long time. And I really appreciate the care and the focus on my individual needs when the company was born. And we've persisted in that mode for the last 20 years. Over those 20 years, NBOSI's maintained a very strong relationship with both the Woods Hole Oceanographic Institution, WHOI, and another contemporary WHOI spinoff, Hydroid, which is now part of Huntington Ingalls Industries. And we have been fortunate to equip many variants of the hugely successful Remus line of AUVs with our sensors. We're super proud to support HII and the US Navy and all of our global allies that use Remus vehicles. And because of this partnership, this long-standing partnership, it is entirely possible that there are more NBOSI CT sensors on AUVs worldwide than those of any other manufacturer. and yet nobody knows who we are. We make use of all the same modern computer-aided design tools and manufacturing methods as the larger companies. And we've developed some highly accurate and efficient calibration processes so that even though we're small, we can provide high quality sensors at a reasonable price. A couple numbers for you. Since joining the company last summer, I've worked hard to sort of streamline our operations. I've taken some baby steps toward enhancing our global visibility, and the early signs are positive. After fairly consistent returns over the past 20 years, we're on pace to triple our average sales this year. We expect to sell our 1,000th sensor in the first half of 2024. And we've got some exciting new products due to be released early next year. We feel it's just the beginning, and we're hoping to continue to be a small company that makes a big impact.
As you know, there are many CTDs on the market, and I'm certainly not looking for you to bash the competition, but can you tell me what specifically makes the NBOSI offering unique?
Sure. Well, you'll get no bashing from me. I think at one point or another, I've probably been a customer of many of the CT manufacturers on the planet. And there's a lot of good sensors out there, and it's not our goal to compete with all of them. But there are some sensor technologies and their implementations that are simply better suited for certain purposes than others. Take as an example, there's some highly refined sensors out there which enable extremely accurate measurement of salinity. And these types of measurements are crucial for understanding large-scale ocean dynamics and quantifying climate variability, especially in the deepest waters. But this accuracy comes at the cost of size and power, fragility of the sensor, potentially complex plumbing, and the need for constant at-sea calibration. None of those are consistent with autonomous operations. And on top of it all, those sensors can be quite expensive. Fortunately, that sort of extreme accuracy really isn't required to capture operationally useful temperature, salinity, and sound speed measurements in the environments where most autonomous operations are conducted. So at NBOSI, we focus on developing low power, low cost, robust sensors that are specifically tuned for mobile platform. Our goal is to provide a sensor that's reliably accurate at a level appropriate for the customer's mission. We design our sensors to be free flooding so that you don't need noisy, energy-intensive pumps to achieve high quality. We embed a fast response thermistor right in the middle of the conductivity cell to eliminate salinity spiking. And we build our sensors to be as compact and hydrodynamic and easy to integrate as possible. Importantly, our enclosed field electrode-based conductivity cells can be calibrated independently from the vehicle on which they're mounted. This is an important factor both for initial integration with a platform and for reducing the operations and maintenance costs associated with keeping your sensors calibrated on a large fleet of vehicles. There are other sensor technologies out there. One of them that has been very successful of late in many venues is based on inductive conductivity measurement. Inductive measurements can be as accurate as electrode-based systems, no question about it, and they certainly have their place. But integrating a toroidal cell that's both hydrodynamically and structurally consistent with a vehicle's purpose can be really challenging, especially when you also have to maintain separation between that cell and the vehicle itself to avoid a proximity effect that impacts the cell's calibration. These are known issues. And we've chosen a technology that allows us to really optimize the measurement for vehicles that have tight constraints on both hydrodynamic efficiency and universal mounting. We never know where a sensor is going to need to be mounted on a vehicle, and we're able to adapt to that. So just to be clear, we're not suggesting NBOSI is the best CTD. We're suggesting that the combination of our unique sensor technology and our custom design capabilities can provide the best solution for a very specific problem, and that's reliable, affordable measurement of temperature and salinity on mobile autonomous platforms.
Dave, it's a big world. Where do you see opportunity today, either by market niche, by region, or both, for NBOSI in the coming 12 to 24 months?
Sure. Well, I don't think we're unique in this, but we see tremendous growth globally in the small and micro AUV markets. These platforms are enabling new users in all categories, science, defense, energy, resource management, new categories that we haven't even thought of yet, with their great capabilities and lower cost of entry. And as I said earlier, we believe that all platforms in the ocean should be measuring the fundamental characteristics of their operating environment, temperature and salinity. But sensors for small vehicles are substantially constrained by power, size, and cost. It doesn't do you any good to build a small vehicle if you can't equip it with sensors to perform a mission. So we're responding by further miniaturizing our sensor electronics and moving towards an even more compact and completely self-contained sensor design that will be easier to integrate, calibrate, hot swap in the field, and otherwise support these new small AUVs. We're on track to roll out this new sensor in early 2024, and our customers are already finding both the concept and the expected pricing very appealing. We can sell a sensor for a huge AUV that is relatively easy to integrate and that will support that vehicle's mission. When we start talking about these micro AUVs, particularly the very smallest ones that are intended to be used in swarms of tens and hundreds at a time, it becomes challenging. And we want to accept that challenge. We are not trying to sell an off-the-shelf sensor that will fit everyone. We want to work with our customers and develop the best solution for the entire spectrum of autonomous platforms.
Can you share details on a recent or an ongoing case study? Insights on how one of your customers has used your technology to help meet and exceed its operational goals?
Sure, Greg. I can't provide a great amount of detail on any one engagement, but I can give you a sort of an overview of some areas where we've had success lately in supporting a few customers with unique requirements. In the past year, we've provided a number of custom sensors for a brand new class of mine hunting vehicle built in Japan by Mitsubishi Heavy Industries. And first response from them is nothing but satisfaction. So we are super happy, again, to be supporting. It's a defense-related application for one of our allies, and it gives us sort of great satisfaction to know that we are contributing in that way, and that our technology is supportive of brand new vehicles, organically built in Japan. Recently, we supported Cornell University with a specially configured and calibrated sensor for a remote study of a deep brine pool in the Gulf of Mexico. So this is an autonomous measurement made in an area where other CTDs may have been applicable, but they probably would have been destroyed because of the harsh environment. So our unique sensor technology allows us to really operate at some of these extremes. And we do have experience in supporting academic research of this type. And finally, we're extremely proud to be offered as standard equipment on the new Huntington Ingalls Remus 300. This is the cutting-edge vehicle on which the U.S. Navy's new and massive Lionfish small UUV program is based. And we worked with them from very early in the design process to have a sensor that would integrate flawlessly and seamlessly with their highly modular vehicle. So in all of these cases, we engaged with our customers early in the design process and offered them a combination of our well-tested sensor technology and custom engineering support. And the end results have been fantastic all around. We're constantly speaking with new customers about prospective applications, and we've got some exciting new collaborations lined up for next year.